Welcome back. This lesson we're going to be looking at differentiating with negative powers. And the good news is that the formula or the rule that we use stays the same. So if we have any function where we have a coefficient with an x term and a power of n, then the derivative is equal to the coefficient times that original power multiplied by x with a power dropped down by 1. So differentiate the following. We've got 3x to the minus 2, and remember from our last chapter as well, every individual term, if they're separated by a plus or a minus, we can just differentiate them one by one. So this function here doesn't really give us a notation. I'm just going to call that f of x, just for the sake of notation's sake. So the derivative would go the coefficient, which is 3 times negative 2, would be negative 6, and then the power drops down by 1. So from negative 2, it's going to go down to negative 3. Just be careful with the negative direction. Plus 5x to the negative 1, let's times that coefficient by negative 1, so we get minus 5x to the negative 2. And now we've got plus 6, which is 6x to the 0. So 6 times 0 is going to be 0, so that's it. There's our answer. Looking at part B, it's a little bit more complex. We've got, again, no function here, so I'm going to call it f of z equals f of z, where z doesn't equal 0 because that wouldn't exist. So this we can write as z to the negative 3 times 3 plus z. Okay, I'm just trying to write this with the negative powers to make it a bit easier for myself. So that denominator of z cubed, I'll put up here as to the power of negative 3. So let's expand the brackets out. I'd get 3z to negative 3. This is our original function, not the derivative. So 3 is z to the negative 3 plus now z to the power of 1 times z to the negative 3. We've got to add those together, so we get z to the negative 2. And then to do our derivative, we just treat each individual term as a separate function. So negative 3 times 3 is negative 9, z to the negative 4, drop the power down by 1, and then we get minus 2 times 1, so we get minus 2z to the negative 3. And that's our final answer. Now, what I didn't show you last lesson is how to use your Classpad. So if we type in these original functions, so I've got 3x to the negative 2 plus 5x to the negative 1 plus 6. If I want my CAS to differentiate this for me, I can highlight the whole thing, go interactive calculation diff, and you can see it's got my expression in terms of x. I've got to tell it what variable I want it in, and click OK. Uh-oh, what have I done there? Let's try that again. Let's go interactive calculation differentiation. Alright, and then let's try our original one that we started with. So that was x squared. See if this works. X squared plus 2x. Okay. No, that's giving me something weird too. Why is it doing that? There we go. Okay. So 2x plus 2, which we know. So let's try that. Let's put in 3. Hopefully this works. If not, I'm going to have to do some video editing and I can't bother doing that. Plus 5x to the power of negative 1 plus 6. Fingers crossed, drum roll. Does that look right? I'll have minus 6 minus 5, which would cancel. Yeah, that would equal the same thing down here. So minus 6x to the negative 3. Obviously, I've got minus 1 times 6. That'd become x minus 3 at the top. They've just put it as a positive power where they can. And then 5x to the minus 2. You can see there's an x there, which would cancel off with one of these ones down here. So it becomes minus 2. And then you've got a negative 1 at the front. So they're equal to the same thing. That's good. However, you can see by hand, my algebraic working out doesn't look exactly the same as here. The calculator, where it can, is going to give you positive powers. And likewise, we could do this one down here. So let's just delete all that. Now I'm just going to place an x in there just so my calculator doesn't melt down. I could put z in there, I just have to change that to d to z. But let's change all this to 3 plus z. X. I'm going to do x, aren't I? 3 plus x and x cubed down the bottom. Execute. So negative 2 x to the negative 3. Yep. And negative 9 x to the negative 4. Perfect. Okay. So to get there, interactive calculation diff. For some reason, it wanted the assist on. Otherwise, I'll have to figure out why it's doing that. If I change that back to standard, it gives me a set of values that are 1 apart. So there must be something. Maybe if I get rid of that. Let's go. Interactive calculation diff. What if I get rid of that? And put in this. Nope. Alright. So for some reason, leave assist on. And then it gives me the right answer. But it's going to give you positive powers. Alright, that's 17C. Most of them you'll be able to do by hand.